All right, and we should be live with everything set up. Just gonna send this link right here. And done. And so what we did was, well, I was doing my question and then my laptop shut down because I forgot to plug it in and I have not got myself some water. I need to do this before starting streaming, but I always forget. I just want to get done with my 3 questions for the day quickly. I have not revised all the concepts I learned, so I need to do that too. I'm gonna do that. So for now, let's just do 2 more questions, easy questions, right? Because we did one hard recursive problem. And I'll start streaming my screen. Right, you should be able to see that. Now, uh, so we've got as recursion, right? We did this question, and now we need to do 2 more. 2 more questions. Prefix to postfix, we can do that. Or we can, well, we were doing bit manipulation, right? Before the stream ended, I was doing this question. So it's got a couple of constraints. That power can be -2. Okay, so we need to create a function which calculates x raised to the power n. And so we obviously need to create an exponential power function. What we were doing is we were breaking the problem down. I'm gonna close all of these. Yeah, I want to do that too. I want to build a YouTube clone too. Right, so I'm gonna close all of these. Yeah, not Excalibur. And right, so x and n, we've got a relation between that because both x can be negative and n can be negative. So if they are, oh, where is my Excalibur? 1, 2, 3, 4, 5, 6, right? So if x is negative, then if the power is odd, then you set the Boolean to be negative, right? That's all you do. That's all you need to do. So if n is less than 0, and it's not it, and uh, n into just minus n and 1. If n is less than 0 and minus n and 1, that means it's odd when negative power is true, and then we need to convert n into a positive number. So we do exactly that. Right, we're done with that. So, and if, yeah, that works. Handle the negative case, and the positive case is just normal. On the other hand, if the power, no, this was the power, wait, my bad, my bad, my bad. So if the power is negative, we check if the power is negative. If it is, then we set the Boolean to be true and we make the power positive because it just means that it's 1 upon something, right? 1 upon what? That's the power that we are gonna calculate. And if we make negative number equal to false, So if x is less than 0 and x into -1, or does minus x work? I think it works. Minus x and 1 if it's odd, because if it's even, then the negatives are going to cancel out. Then you said neg num equal to true. All right. And now you pass in and you convert x equal to x into I need to put this in a condition. I'll do this inside. So if it's negative and if, so I gotta do this regardless, right? X is equal to star is equal to -1. We convert this into positive, and then if x and 1, then neg num is true. Right, we're done with that. Now n is less than 0, neg power equal to true, x is less than 0, neg num equal to true. Right, now we're gonna pass it in the function x power, and x comma n. Now we can assume that it is positive. There is only one case, that is if n is -2 raised to the power 31, because then my like then the int cannot handle it. So what I can do is just create a long int, right? That's one way to handle it. So I'm thinking of doing that actually. Let's just do that. So like for n star equal to 1, star equal to -1, and power, I mean it's gonna be long. And right, so we've handled the -2 raised to the power 31 edge case. Gonna open chat. Hey bro, Alok Desu. Oh, hey man, what's up? Didn't expect you on the chat. All right. So you must have solved this question out. I'm doing this for the third or fourth time, but it just trips me up every time. Right. And then x power x raised to x comma power, and I return that. No, I'll store that as an answer. So double ANS equal to, because I need to do other stuff to it. Right, so here we have x that is positive and n that is positive, and a map that I want to use to memorize the function. Yeah, do you code in C++ too? Right, so how do we go about this? So as I was discussing the base cases, what you basically do is if n is odd, you break it down into x into x raised to the power n minus 1. So I'm going to do exactly that. If x and 1, that means it's odd, return x into x for x comma n minus 1. Else, that means it's even. You return double n is equal to, just a second, I am getting an important call. Right, we're back. Just my mother worrying about me. That's fine. Look, I don't have to be concentrated. This is just a chill session. I'm supposed to take a break today. It's Sunday, but I don't know why I did not take a break. I feel incomplete without doing my questions, something like that. So double answer is equal to x power x comma n by 2, and you return answer into answer. And what I need to do is equal to, so you declare this, and then if memo.find is that or how you do it? I think it is. So it's got a pair and a double. It's gonna be x comma n by 2 and that returns me an iterator is equal to answer is equal to memo dot end map find cpp. I need to check what this returns. Right, find, and then you give it the key and it returns the iterator. It returns an iterator to the end if it's not found, iterator to the position if it's found. That means that my implementation is correct, and if it's not found, then answer is equal to x pow x comma n by 2, else, and then you gotta push it back memo, and I need to pass this in by reference, so it's a nice table. Memo x comma n by 2 is equal to answer, else answer is equal to, so I need to make this an equation, like what's this called, not a comparator, I don't know what's it called. Answer equal to memo x comma n by 2, and then you return answer into answer. Right, so if it's not in the map, then you calculate it and then you add it to the map. If it is, then you just use it from the map. And then you return answer into answer. Mm-hmm. Should I memorize this too? I don't know why I haven't memorized this. So how do I memorize this again? If memo dot find the key x comma n minus 1 is equal to memo dot end. If it's equal to, that means it's not in the map, then I'm gonna create the same variable here. Double ans is equal to xpw x comma n minus 1 xpw x, no, and then you add it to the memo. This is x comma n minus 1 is equal to answer, else answer is equal to memo x comma n minus 1, and then you return this into answer. Now both of them are memoized, and I just return a random arbitrary value, I think. And finally, add a base case. If n is equal to 1, return x. If n equal to 0, you return 1. So these are the base cases handled. Right, and then how do you return the answer if negative power is true? Wait, basically, so if it's a negative number, I am a little confused right now. So if the number is less than 0, it doesn't matter what the number is. If the power is odd, power and 1, so power is always going to be positive because of this right here. But if the power is odd, then the number is going to be negative. Am I right? I am right. And if it's even, the number is going to be false. So if negnum answer star equal to -1, and if neg pow answer equal to 1 divided by answer, and then you return the answer. I'm just gonna do this and then this. and that should work. Invalid operands to binary expression double end. Okay. Line number 6. Operands to binary expression double end. So if it's a double, you cannot do bitwise operators on it. Well, isn't that shitty? I don't even know how these are stored, so I'm just gonna do a normal. Expression 2 is not equal to 0. This means it's even. It's not even. What? Operands to binary expression. Invalid operands to binary expression double and int. How is that a thing? Error invalid operands to one means you're trying to use modulus between double and int, but person only works on integers, not on floating point numbers. Okay. I'm not even supposed to check x. I'm supposed to check the power. What's wrong with me? If n and 1. I'm not even supposed to check x. I'm supposed to check n. Answer equal to this. Memo, and then is there, where do I call expo? Again here, we do memo. I'm passing memo here. Right. Forgot to pass that one. Okay. Accepted, accepted, accepted. And submit the solution. Got a seg fault if x is equal to 1. That is a case I should have handled. Still can't submit. Two is I think this I think this was int min, or it's not. Whatever it is, what is it doing? It's address signed as a dead signal. Stack overflow. Double. It's a double. And it's an is that it? Oh, I forgot to. Is that why I'm getting an error? Because it's trying to store it in the memo. No, it's not. I'll have to check. Close, but I see the problem. In your helper function, access double n is input in my power. You for it like right. This should be a long because it can't handle negative int min. Yeah. Okay. So this should work now. That's really nice. But this is not the most optimal solution? This the most optimal solution. No, it's not the most optimal. You're using memoization, but it costs extra time in order to manage the map. And actually, you need memoization. Binary exponentiation. Without any map, pure recursion or iteration works in O-log in time. So your total time is a bit worse than O-log n because of the overhead. Comparing doubles is tricky and maps are not case friendly. So I can using binary exponentiation though. Yes, you are improving the core idea, splitting into halving, but not clean because you're adding memoization necessarily. Is memoization may how is memoization making it worse? Am I not saving recursive calls? You solve the same subproblem multiple times. Trees used in overlapping. Memoization saves a ton of repeated work. And problems where you recompute the same thing again and again. Memoization is, are you saving recursive calls in your current binary exponentiation setup? No, you don't really have a repeated subproblem because every call to this is a new unique value. Once you split and you never ask for the same one again. That is true because only one branch has, like one level has it. Man, I might have done a whole lot of work for nothing. So if I just remove this and I remove this and this, get rid of this, right, get rid of this and this, and finally this, then my solution should still work. I've got to get rid of this. My solution should still work. Right, so many memos. My solution should still work, but it should also be faster. Code carrot, 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 carrot. Saving to Google Sheets. Save to Google Sheets. Uh-huh. Then with another problem. Find prime factorization number using sieve. Sieve for Eratosthenes. Two numbers appearing odd number of times. Given unsorted array of size n that contains even number of occurrences for all numbers except two numbers, and the two numbers in decreasing order, which has odd occurrences. So it's an unsorted array, and it's got an even number of occurrences for each number except two numbers. Two numbers in decreasing order, which has odd occurrences. So usually with these questions, there is a pattern of XORing, like XORing all the numbers. But like if all of them were even and I only had one odd number, then XOR of these would bring me the solution, right? But right now, if I XOR these, I'll have nothing but gibberish because there's two numbers that are odd. Uh-huh, uh-huh, uh-huh. Man, if it's different, you get one. If it's the same, you get zero. So if it's different, you get one. Right, so five for 5 and 1 you would get what's 5? 101. And for 1 is this. You will get 100. Xoring all of them, you get this number, which is essentially what 4. You get that. But what use is that? Such no fucking use. So if I start adding and then xoring, what's that gonna do? And that does nothing. Can I get an end? Expected time complexities of n. So I need to do this in a single traversal. So 4. What you can do is take 4, XOR it with each number, take 2, XOR it with each number, and then in the end you end up with fucking nothing because you XORed the odd occurrences too. Oh god, this is Couldn't even solve this last time. So how do you do this again? I'm going to take a look at the solution.
So time to continue with our bit manipulation. Just before that, we will go back to the channel. I hope you guys are doing
Let's
pretty well.
get a look at this.
We will be solving today is single number.
Part 3. The part 1 and part 2 have been solved in the previous videos. In case you haven't seen them, go back and watch it. Where every number will be occurring twice. Every number will be occurring twice, but there will be two numbers, two distinct numbers that will be appearing once. Let me explain. So if you see two, they're appearing once. So if this problem comes up in an interview, the extreme name solution that I can think of is hashing, right? So can I hash the numbers and their frequency? Probably yes. So what I will do is, I will take a map data structure. The next number will be 4, 1. After that to the next, traverse again in the map, not in the array. You can traverse integer as the key and integer as the put. Programming languages, the iterator might vary. So I'll go through the map.
That's a shitty solution that you just proposed, so I'm gonna skip over that.
So I'll write second, if id dot second is 1, which means, yes, this number is appearing once. So I can say, okay, so once you would have finished iterating, your answer would be storing, for this particular example, 4 and 6. So what you can do is, you can go ahead and return answer. So what will be the time complexity? Let's analyze. So this will be n logarithmic size of map, which is m. What will be this? Size of the map, bgo of m. Very simple. Again, I'm taking logarithmic of m because I'm assuming that the map is taking logarithmic. If you take something as an unordered map in C++, it might take bgo of 1. Again, depending on your programming language, time complexity of map might vary. So you can analyze according to that. So I can write the time complexity as n logarithmic m plus bgo of m, whereas the space complexity is bgo of m for storing all the elements in the map data structure. How many elements are there? So I'm saying all the elements are appearing twice, right? And there are 2 elements storing in the map. I'm storing 5 elements. So that's basically 8 by 2. Yeah, that's how easy it was. So obviously the interviewer will not be happy with this one because we are using an external data structure and he'll ask you to optimize it. So in order to optimize the brute force, I'll be using the concept of map. Simple. Again, I'm taking 4 and 6. You can go ahead and return and storing, which is m. Analyze. So this will be n logarithmic size of map, which is m. What will be this? Size of the map, bgo of m. Very simple. Again, I'm taking logarithmic of m because I'm assuming that the map is taking logarithmic. If you take something as an unordered map in C++, it might take bgo of 1. Again, depending on your programming language, time complexity of map might vary. So you can analyze according to that. So I can write the time complexity as n logarithmic m plus bgo of m, whereas the space complexity is bgo of elements for storing all the elements, right? And there are 2 elements which are appearing once. So if I count 1, 2, 3, 4, 5, 6, 7, 8, and how many am I storing in the map? I'm storing 5 elements. So that's basically 8 by 2 plus 1. Near about that? Yes. Because obviously the interviewer will not be happy with this one because we are using an external data structure and he'll ask you to optimize it. So in order to optimize the brute force, I'll be using the concept of bitwise operators. Now to be in the nums array, what I'll have once. So I'll take 14 and I'll take 4. Now what I'll do is, I'll XOR everything. So if I XOR down everything, what I'll have 0 and 4 is 4, so that's 1, 0, 0. If I take a XOR, this is what I will get. That's basically 8 plus 2, 10. So the XOR that I'll get is 10. If I ask you, this 10, what is this? This is nothing but XOR of 2 distinct numbers, which you're looking for, right? You're looking for these 2 numbers, and 10 is the XOR of these 2 distinct numbers. If you look at the XORs, like binary XOR, do you observe something? There would be a minimum of 1 bit, which is different. There would be a minimum of 1 bit, which is different. Over here, there's a 1, there's a 0. So 1 bit is different. The second bit is like, there are 2 bits. There are 2 bits which are different in 14 and 4. Why is that? Because both of them are distinct numbers. So I'm very sure if there are 2 distinct numbers, which is already told to us in the question, I'll always have a minimum of 1 bit which is different in them. Now all the bits cannot be same because both of them are 2 distinct numbers. Minimum of 1 bit position will be different in them. Agreed? Keep that in mind. Keep that in mind. So what I'm saying is minimum of 1 bit index or bit position will be different. So the number is 10, which is 1, 1, or rather 1, 0, 1, 0. Now I know one thing, because I did a XOR, I got 1 and 1 at the bit index which were different. So these 2 bit index were different in both of these numbers. In both of these numbers, I know it. Now the next step is to use the concept of buckets. Now for that, what I'll do is I'll either take this bit index or I'll either take this bit index. You can take either of them. It will be working fine. Now the easiest way is to get the rightmost bit. So I'll be taking the rightmost set bit. I'll be taking the rightmost set bit. How can I do it? Again, it's very, very simple. Do you remember one thing? I told you if the binary is something like 1010100, and if you write number minus 1, I've already told you this in my previous lecture. If you write num minus 1, what will happen is, and the left stays as it is.
3 years, 3 cities, for an experience like you've never had before. You want it all.
So this is the binary of number minus 1. So what you will do is, you will do an AND of it. You will do a AND of it. So when you do an AND, what you get is 0, 0, 0, 0, 1, 0, 1. So if you carefully observe, everything to the right of the rightmost bit was turned to zeros and the left was copied. Okay? And the next thing is very simple. You will take a XOR and you will do the XOR with the original number. So if you do this, what will happen is 1, 0, 1, 0, 1, 0, 0. This was the original number. So if you do a XOR, you'll get a 0, 0, 1, 0, 0, 0, 0. So what you did was, you basically got this number. So you basically got a number where the rightmost bit is turned on to zeros and the left was copied. Okay? And the next thing is very simple. You will take 1. So if you carefully observe, everything to the right of the rightmost bit was turned to zeros and the left was copied. Okay? And the next thing is very simple. You will take a XOR and you will do the XOR with the original number. So if you do this, what will happen is 1, 0, 1, 0, 1, 0, 0. This was the original number. So if you do a XOR, you'll get a 0, 0, 1, 0, 0, 0, 0. So what you did was, you basically got this number. So you basically got a number where the rightmost bit is turned on. And that is very simple. Initially you took the number, let's assume you took the number, and then you said and with number minus 1. Okay. After that you did and everything as zeros. The rightmost bit and everything else as zeros. Okay, so you know the concept now. So can I say, if I do this on this number which is 10, what I will get is 1, 0 and everything as 0. I'll get this number which is nothing but 2. So apply this operation and you will get it as 2. Now what is 2 signifying? You have the rightmost bit turned as 1. If I ask you a very simple question, 14, what is that? 1, 1, 1, 0. 4, what is that? 1, 0, 0. So 14 is this, 4 is this. Have a careful observation. This is the first bit from the right. This is the first bit from the right. So if I take 2 buckets, concept of buckets, if I take 2 buckets, can I say 14 will be in the first and 4 will be in the second, assuming the first bucket is storing all the first bit which are 1, all the first bit which are 1, and this is storing all the first bit which are 0. First, I was able to separate 14 and 4. I was at least able to separate 14 and 4 on the basis of first bit because that bit was different in each other. So because of this, 14 would go here and 4 would go here. I was able to separate them into 2 different buckets. Very simple, very, very simple. Okay. I'll not get into the buckets, but I hope you've understood how do I separate them into 2 buckets. On that, on the first bit, I'll be separating them into 2 buckets. Fine. Let's take bucket 1 and let's take bucket 2. And now let's start traversing. What is 2? 2 is 1, 0. If I write 2, that's basically 1, 0. First bit is turned 1. So I can say this will be having everything which is turned 1 and this will be having everything which is turned 0. So the first bit is turned 1, so it will go into the bucket 1. Next number is 4. What is 4? 1, 0, 0. The first bit is 0, so it will go to the bucket 2. Next is 2. Now I know one thing.
Hi back, I'm Dad. I don't know why this joke was stuck with me ever since the dad joke era on YouTube and Instagram. This joke is just completely stuck with me.
It will always go into the same bucket to which the previous 2 went. Okay. Turned 0. So the first bit is turned 1, so it will go into the bucket turned 1 and this will be having everything which is turned 0. So the first bit is turned 1, so it will go into the bucket 1. Next number is 4. What is 4? 1, 0, 0. The first bit is 0, so it will go to the bucket 2. Next is 2. Now I know one thing. It will always go into the same bucket to which the previous 2 went. Okay. Next, 14. What is 14? 1, 1, 1, 0. Turned 1. So 14 will be there, right? Next is 3. What is 3? 1 and 1. Turned 1. Next is 7. How much is that? 1, 1, 1. Will go over here. Next is 7. 1, 1, 1. It will again go here. Next is 3. It will again go here. Now the beauty is, I know one thing. 14 and 4 will definitely go to bucket 1 and bucket 2 separately. They'll not be in the same bucket. And all the other numbers like 2, they're appearing twice. So either they will go to bucket 1, both of them will go to bucket 2. They cannot go to different buckets. So eventually, at the end of the traversal, you will see this, that the bucket 1 is only having one number which is appearing once, and all the other numbers are appearing twice. All the other numbers are appearing twice. If bucket 2 had more numbers, just imagine for that reason you had something as 8. Just for an example. Let's take instead of 3, if I would take, give me a second, yeah, instead of 3 I'll take 8. In that case what will happen is 8 instead of going here will go here. But both of the 8 will go into one bucket. So if I do a XOR, since all these numbers are appearing twice, they'll cancel off each other. So if you do XOR of all the numbers in bucket 2, you'll get 4, because all the other numbers that would be in bucket 2 would get cancelled. Same with bucket 1. 2 and 2 would get cancelled. XOR of two same numbers are 0. 7 and 7 would get cancelled. 3 and 3 would get cancelled. So eventually the XOR will be 14. So anything that gets to bucket 1, when you do a XOR, at the end it'll have that one element, because all the other numbers are twice. Very, very simple. Very, very simple. So the bucket was taken so that we could differentiate 14 and 4 into two different. Once you have done it, you know all the other numbers will always come in pair, So they could XOR themselves and they'll be 0. Got it? Okay, time to write down the code. Now you might be thinking, oh goodness, the code is going to be super tough. No, it's very, very simple. One thing, you don't have to take a bucket. You don't have to take a bucket. Like, you don't have to take a data structure. I'm just taking the numbers. And at the end, I'm doing a XOR. So while taking the numbers, instead of storing them into a bucket,
You just store them in instead of a bucket in just the number, right? That's so cool. I need to plug my phone in. Give me 10 minutes. I'm gonna join you then. That's fine. I need to plug my phone in first. So that should be okay now. Just check if camera's okay. Right there. Got it.
XOR them as you move now. Very simple, right? Something like 7 and 7 will go up and you'll be left. Oh, I need a number so that the rightmost bit is turned 1. The rightmost bit is turned 1. It's set as 1. Why did I take it? Took it for a very simple.
This is just really cool.
And let's play. So I'll take bucket. Initially I'll take the XOR. I'm doing a XOR. So while taking the number,
I'm gonna write the code on my own and then I'm gonna continue watching the video. Right. 2 odd numbers. I need to mark it right here. In num1, let's just take a long. I'll just do them because alias for long end. Right, okay. Where's my thingamajig? Where's my, I can find it right there. Right, so these are the same long num1, long num2. Find this, and then, well, I equals 0. I is less than and I plus plus of size and ARR and so this should be equal to 0 in the beginning, and we get this number, and then we create a bit mask. Zone and zone -1. So no, it's whatever. So 14 or 5 or 1, and the other one -1. Gonna give me that. Gonna make it all 0, and then I do a zone with that. So I just get that mask. All right. For I equal to 0, I is less than n, I plus plus if array, oh, should be n, should be I. If array I, so I need to check if that mask is active on one of the numbers. So if array I and mask is equal to 0, then I'm gonna put it in and initiate all of these as 0. 1 equal to num1. So array I else num2 equal to num2. So array I, and in the end return num1 num2. Does this work? Let's see if this works. Returns me the wrong output. Fuck you, man. I hate this fucking website. Why is the output 0? It should not be 0 in any fucking case. Man, I'm so sure these are correct. I'm so sure these are correct. Alright. Even if it was in, like, I should have gotten at least num1 right. Output is 0 and 4. And how is it 4? Bro, I don't see why. And has lower precedence than I would have never thought of that. Holy shit, that's such a nice thing to know. I swear to God, if this tripped me up in an interview, I would have killed myself. Thank God, I'm learning right now. I get 1 5, and I need 5 1. I need to find them in the decreasing order. Why is that relevant? So this will always give me the higher number first, right? No, it won't. I need to sort this. Let me see. Let me see. Let me see. Let me see. I don't think it's gonna be sorted though. Right. I'm just gonna 2 is greater than number 1. Now that should work. That's nice. What's GFG 160? One sixty days of problem solving. One problem daily with GFG 160. In-depth articles, blah blah blah. Get free access to exclusive career sessions on trending technologies. Well, something. But I am done with my questions for the day. Isn't that nice? One problem here, 4 problems here. Hush. I'm gonna go get some dinner. I need to get some dinner. So we've got the same number of easy and hard problems, and I completed almost all of the easy ones. That does not give me hope. Ah, right. Well, I'm done. I'll probably be working on my YouTube clone now, and I'll do another stream for that. But I'm done with today's questions, and I'm gonna see you guys on the next stream. Ah, the day is almost over.